There is a Canadian astronaut flying to the moon right now. But here's a question that many people don't ask. Why is there a Canadian on an American space mission? The answer involves one of the most important tools ever sent into space. A robotic arm designed and built in Canada, which helped construct an entire space station and which has been flying above our heads for over 40 years. This is the story of the Canadarm, the deal that started everything. Back in 1969, NASA was designing the Space Shuttle, a reusable spacecraft that would carry astronauts and equipment into orbit over and over again. NASA needed a robotic arm that could be mounted on the outside of the shuttle to grab satellites, move cargo, and help astronauts during spacewalks. NASA noticed something interesting. Canada had already built a robot arm for a very different job. A Canadian company had designed a robotic system to remotely load fuel into CANDU nuclear reactors, Canada's unique type of nuclear power plants. The arm was precise, reliable, and operated in a dangerous environment without a person touching it. Exactly what NASA needed. So NASA made Canada an offer. You build the arm for our space shuttle, and we'll give you space on our missions. Canada said yes, and a historic partnership was born, building the first Canadarm. A Canadian company called Spar Aerospace got the contract to build the arm. Their engineers worked out of a plant in Toronto, Ontario, and spent years designing something that had never existed before. A robotic arm, tough enough to survive the extreme cold of space, smart enough to handle delicate equipment worth millions of dollars, and light enough to fly on a rocket. Building in space is very different from building on Earth. There's no gravity, so even small movements can send a giant object spinning. Temperatures swing from over 120 degrees Celsius in sunlight to minus 150 degrees Celsius in shadow, and if something breaks, there's no one nearby to fix it. The engineers solved every one of those problems. The arm was made of a special lightweight material called graphite composite, the same kind of carbon fiber material used today in racing bikes and aircraft. At 15 meters long, it was roughly the height of a 5-story building, but weighed far less than a car. The completed Canadarm was officially handed over to NASA at Spar's Toronto plant in February 1981. It first flew into space on the Space Shuttle Columbia in November 1981, and it worked perfectly. Over the next 30 years, the Canadarm flew on more than 50 Space Shuttle missions. It launched and retrieved satellites, helped repair the Hubble Space Telescope, and moved equipment and astronauts during spacewalks. It became so iconic that the image of the Canadarm was printed on Canada's $5 bill. Enter Canadarm2, building the space station. When the space shuttle era ended, Canada was ready with something even better. In 2001, Canada launched Canadarm2 to the International Space Station, ISS. If the original Canadarm was impressive, Canadarm2 was extraordinary. At 17.6 meters long, taller than a 6-story building, with 7 motorized joints, it could bend and move in almost any direction. But its most remarkable feature was the way it moved. Instead of being fixed in one place, Canadarm2 could crawl along the outside of the space station by attaching and detaching from special sockets called Mobile Remote Servicer Base System, or MRBS ports, kind of like an inchworm gripping different points of a branch as it moves along. This meant Canadarm2 could reach any part of the station, from any angle. Without Canadarm2, the International Space Station could not have been built. Every new module that arrived, every solar panel, every laboratory, every connecting tunnel was grabbed, guided into position, and bolted in place by Canadarm2. It took the work that would have been done by hundreds of construction workers and compressed it into one tireless robotic arm, operating in conditions no human could survive unprotected. Canadarm2 is still active on the ISS today. Alongside Canadarm2, Canada also contributed a smaller robot called Dextre, a two-armed handyman robot that can perform delicate repairs and replacements on the outside of the station. Dextre can replace batteries, swap cameras, and even refuel spacecraft, tasks that used to require a spacewalk. Canadarm3, Canada's robot for the moon. Now a new chapter is beginning. The company that built Canadarm2 and Dextre, now called MDA Space, is headquartered in Brampton, Ontario. In June 2024, MDA Space was awarded a $1 billion contract from the Canadian Space Agency to design and build Canadarm3, a new robotic system for future moon missions. Canadarm3 will be smarter than any arm before it. It will use artificial intelligence to operate autonomously, meaning it can carry out complex tasks by itself without a human controlling every movement. This is necessary because the moon is far enough away that radio signals take about 1.3 seconds to travel there. In a situation where precision matters, 1.3 seconds is too long to wait for a command. Canadarm3 is actually a system of two arms, a longer arm about 8.5 meters long for large movements, and a smaller, more precise arm for delicate work, similar to how a human has a whole arm for big movements and a hand with fingers for fine tasks. It will also carry a small tool caddy to transport equipment around whatever outpost it is attached to. The engineers are working from MDA Space's Space Robotics Center of Excellence in Brampton, which will also be the mission control facility once the arm is in orbit. Why this is a fair trade. Some people might wonder if it's a bit unusual for NASA, an American agency, to bring a Canadian astronaut to the moon, but look at the full picture. Canada has contributed 3 generations of robotic technology to space exploration. The Canadarm flew on over 50 shuttle missions. Canadarm2 helped build and maintain the ISS for over 25 years. Canadarm3 will support humanity's return to the moon. This technology was designed and built by Canadian engineers, funded by Canadian taxpayers, and it made American missions more capable and more safe. In exchange, Canada gets to send its own astronauts on those missions, including Jeremy Hansen, who is flying to the moon right now. It's not charity, it's partnership, and it's how some of the greatest achievements in human history get done. The Canadarm was originally built because Canada had already made a robot for nuclear reactors, which NASA noticed. Can you think of another technology we use every day that might have helped solve a completely different problem somewhere else? Leave your answer in the comments.